Here we're interpreting a mass spectrum. Start with what we know already about the molecule. Being a fruity smelling liquid rather suggests an ester, and the lack of a result with Brady's reagent or Tollens reagent rather suggests that this is not an aldehyde or not a ketone. We could also have tested it with sodium carbonate solution or with universal indicator, and the lack of a positive result there suggests it's not a carboxylic acid. We start interpreting the mass spectrum by looking at the peak furthest to the right. This is the molecular ion peak and tells us the relative formula mass of the molecule. Since we think it's an ester, we can have a look at what the mass for the carbon and 2 oxygens of the ester group would be. Those add up. 12 plus 16 plus 16 is 44. So if we subtract that from the RFM, we can see that the rest of the molecule comes to 44. And we can suggest how many carbons and how many hydrogens that would be. It's looking like we might have a CH3 and a CH2. That's 15 and 29. That adds up to 44. Now we need to match the possible fragments of the molecule up to the peaks in the mass spectrum. A CH3 would show up at 15, so that's CH3 plus fragment. An ethyl fragment would show up at 29, so that's C2H5 plus. And we'll have to work out some of the larger fragments. We could combine the ester and the methyl, so that would be CH3COO. But we could also have the methyl group on the other side of the ester, so we might have C double bond O, O, CH3. That's the same atoms, so it's going to be the same mass. So that's 44 for the ester group and 15 for the methyl. So that's going to be a peak at 59 if that's one of the fragments. And there it is in the spectrum, so we can assign that peak to either CH3COO or COOCH3. We don't know yet which way round that's going to be. We've got this very large peak at 57, which we haven't yet been able to decide what that is. So we need to come up with some other possible fragments of the molecule and match up where they would show in the spectrum. We could see whether the oxygen and the CH3 group are connected together. There we go, so an OCH3 fragment, that would show up at 31. And we do have a small peak at 31, so OCH3 plus may well be a possible fragment ion. We could also have a look at whether the methyl is connected to the carbon of the carbonyl group. That would come to 43. We really don't have much of a peak at 43, so it doesn't look like the methyl is connected to the carbonyl carbon. So let's try the ethyl group there, C2H5CO. That fragment ion would have a mass of 29 plus 12 plus 16 is 57. So it looks like we've found the large peak. And that's also given the information we need to decide which way round the methyl and the ethyl group are on our ester. So we can assign our ester as CH3, CH2, COOCH3 or methyl propanoate.